Hi, this is Mrs. Clark, and welcome to part 2 of my video on the distance between points. Today we're going to talk about the distance formula. Last time we did Pythagorean theorem. We figured out the length of this segment AB. Now we're going to use what's called the distance formula, so I'm going to show you the formula, explain how to use it, and go through the same example that we did up here using the distance formula in order to get that same length. So we'll get the same answer that we got with Pythagorean theorem. It's a different method to solve for the length of that segment. Because it's on a graph, we use what's called the distance formula. So before we write down the distance formula, the first thing we want to do is we want to know the coordinates for A and B. And when I say coordinates, I mean like what are the X and Y locations of A on the graph. So A is at -8, 4. And B is at 4, -4. Okay, we're going to write those again on the inside of our paper, but I want to write them here so you remember that that's how we got them. So first thing I'm going to do is write down the distance formula, and then I want you to pause the video and copy it down. You need to make sure that you're careful to copy down every parenthesis, 2, 1, subtraction sign, addition sign, little square, everything exactly how you see it. And you're also going to want to get 4 different color highlighters if you can. So here's the distance formula. I'll read it to you and you're going to write it down, so if you need more time then pause the video to do that. D equals square root, so big long square root over everything, parentheses x2 minus x1, close your parentheses, squared, plus parentheses y2 minus y1, close your parentheses, squared. D stands for distance. That's why it starts with D equals. The distance between points. So notice it has these little x1s and x2s and y1 and y2. Those are going to be from our 2 different points. And the 2 points that we are going to do this with are the 2 that we just wrote down from the graph above. So we had point A, which was at -8, 4. And we had point B, which was at 4, -4. So when I'm looking at the formula and I see the little 1s and 2s on the x's and y's, I'm going to label these x1, y1, x2, and y2. Alright, so to start the distance formula, I'm going to start with D equals, but because we're finding the distance from A to B, I'm actually going to do D with a little AB sort of down, like you have these little 2s and 1s are sort of down. So that's the distance from A to B. It's just a notation we're going to use. In case we're doing the distance formula for more than, there's more than 2 points on a graph, then we would want to use this to signify which one we're talking about when we're looking at our work. And then what I'm going to do is I'm going to fill in, I'm going to write actually the formula, except I'm not going to write the x2, the x1, the y2, and the y1. I'm going to leave a blank. So this is the shell of what the formula looks like every time I use it. These things do not change. Okay? And what I left a blank for are the things that I'm going to have to, places I'm going to have to substitute in a number. And depending on what number it says in the formula is what number is going to go there. So first I have x2. So I'm going to highlight x2 here in one color. I'm also going to highlight this blank the same color. And I'm going to go over here to my x2 and highlight that the same color. So this is my x2. That's what goes here. So they're all the same color. I'm going to go through and do that with each of the x2, x1, y2, and y1. So pick a different color for x1. Highlight that. The reason we're color coding this is so that we can see when we come back and look at our notes what goes where very easily. And that will help us to make less mistakes. If we can make sure we're putting everything in the right spot, then that means the only mistakes we're going to be making, if we make any, are calculation mistakes. We want to try to eliminate as many careless errors as possible. Okay. So once you have it highlighted 4 different colors, and again, pause if you need more time to write that down. I'm going to go back, and I'm going to actually fill in here the numbers that go in each spot. So my yellow spot gets a 4 because that's my x2, so I'm going to fill that in. Then my next pink spot gets an x1. So after this subtraction sign, the x1 is a -8, so I'm going to put another subtraction sign, but I'm going to put it slightly above so they don't like run into each other. -8. So that I see this is 4 subtract -8. Subtract comes from the formula, the negative comes from the x1. Then I got a plus sign, then I got a parenthesis, then I got my y2. And my y2 is -4, so I'm going to fill that in. And then I've got subtract, and then I got my y1, which is +4, so fill that in. So the first thing we did is substitute everything in. The next thing that we're going to do is we're going to start cleaning up all of our formula, but one piece at a time. So if you remember, you learned this acronym called PEMDAS. Looks like this. P stands for parentheses. And then E stands for exponents. Then we have multiplication and division, working left to right. Then we have addition and subtraction. So we're going to use PEMDAS, this is called the order of operations, to go through this formula and simplify it piece by piece by piece till we get down to one final number. So first thing we're going to do is clean up our parentheses. So what that means is I'm going to pick up my calculator, and I'm going to calculate what 4 minus -3 is, 4 minus -8 is, and get this all down to one number inside the parentheses. And the same thing for this parentheses. So when I go to write my next step, I'm going to have this same notation, the distance from A to B equals, I'm going to have the same square root. It's not going to be quite as big this time because I'm going to simplify it down a little bit. But I'm still going to have a parenthesis squared plus another parenthesis squared. But this is going to be just one number. So I'm going to pick up my calculator. The way I'm going to get what goes in that parenthesis is I'm going to type this in my calculator. 4 minus -8. 4 subtract -8. And I get 12. So this parenthesis is now just 12. Same thing on the other side with -4 minus 4. -4 minus 4. -8. So in this parenthesis, I'm going to put a -8. So the next step, I've done my parentheses, is to look at my exponents. So exponents are these little numbers up here at the top. This 2 over here. So we said the last time when we saw that 2 that it was called a square, and we did 8 times 8 for it. So this means I'm going to have to simplify this piece and do 12 times 12 and get an answer. And then simplify this piece and do -8 times -8 and get an answer. So it's going to look very similar, but a little bit smaller under the square root now. So I'm going to do whatever this is plus whatever that is. So in the calculator, I'm going to do 12 times 12, 144. And then -8 times -8, and I get 64. So I'm almost there. I've done my parentheses, I've done my exponents, there's no multiplication, no division, there's addition, so I'm going to do that next. So the distance from A to B equals 144, square root of 144 plus 64, so let's add those up. 208. So the distance from A to B is square root of 208. So I'm going to type that into my calculator. I'm going to hit the second button. I'm going to hit the x squared button here so I get the square root. I'm going to type in 208. 208. Hit enter, and I've got 14.4222051. So just like before, we're going to look at the third decimal, and instead of 42, it's actually going to stay 42 because the next number after that is a 2 again. So the distance from A to B is approximately squiggly equal sign, equal to 14.42 units. So we got the same answer that we got here. Here we did it using a triangle. Here we did it using the coordinates and the distance formula, but they give us the same answer. So either method is viable when you're trying to find the length of a segment on a graph. Now, I'm only going to be able to use Pythagorean theorem when I can make a triangle. So if I have a graph, I can make a triangle. If I just give you a problem with a triangle, you can use Pythagorean theorem. If I want to use distance formula, I have to have the coordinates. So either I have to give you these, x1, y1, and x2, y2, or I have to give you a graph where you can read them. So distance formula can only be used on the graph. We're just going to write one last piece here at the bottom. We're going to just summarize it all together. And we're going to say the length of AB or the distance from A to B is approximately, now I'm saying approximately because we used our rounding rules to cut off that decimal, 14.42 units. And there we have it. So your questions may ask the length of AB, they may ask the distance from A to B. Either way, here are two methods that we've learned: Pythagorean theorem and distance formula. Thank you for watching. Make sure you let me know if you have any questions.